Hello everyone. In this video I will show you how you can check for criteria for the shape function element. So let's take example, and in this example take it through 2D element. Okay, this is the length, and here x is 0, x1, because I take the element on x direction, and here x2 is equal L, the length of whole number. Actually the x2 here for this point and x1 for this point. I'm sorry, maybe my drawing is not good. And this is here we have the x direction to show you, because I'm going on x direction, and for this element has two nodes, and it's a bar element, and also it's 1D. You can try with yourself if you have 2D and 3D, you will get same result and same rule. So let's assume or take a linear rule for the k equal EA over L 1 minus 1 minus 1 and 1. Okay, and assume for this node, the x1, it's called u1, and the name of x2 node it's u2. Okay, so for the perimeters is equal 0 in this case. That's mean find through initial condition boundary condition. That's mean the initial condition is same is a boundary condition. That's mean for the u equal a plus bx, and here the x is range between 0 to L, because I don't have any value here, just sample. I use sample and letters. So I will take the node one by one. Let's start with node number 1. Node number 1, x equal x1. Okay, this is the general for the u rule. This is general. Now I want to find the value actually of a and b. x1, sorry, the x value of x, I'm talking about the node number 1, x equal x1, and x1 is 0. Okay, that means u equal a plus bx, and the x is 0. The x is 0, so all this part it will be 0. Okay, that's mean u equal a. Okay, because u equal u1. So now go to node number 2. Let's see what is the difference. Node number 2, x equal x2 equal L. Okay, then if you substitute your value in this equation, the general equation of u, you will get u2 equal u1 plus b times L. Okay, then I want to find the value of b, because in the previous node, the node number 1, I find the value of a equal u, but here now I will find the value of b, so that b equal u2 minus u1 over L. Okay, then I can take the summation of nodes with the name of node, that means the u, so that u equal summation ni time ui. The n is the number of node, equal n1 time u1 plus n2 time u2. However, u equal a plus bx equal u1, just substitute this from previous slide, u1 plus u2 minus u1 over L time x. Okay, then equal u1 plus x over L time u2 minus x over L time u1. Then to make it as simple, because I want to get the result or acceptable result, it will be u1 plus x over L time u2 minus x over I repeat, I'm very sorry. Therefore the last result of u equal 1 minus x over L time u1 plus x over L time u2. So this value or this part call n1, and this part is n2 for the node 2. Okay, so then after I get the value of n1, node number 1, and node number 2, it's easy to check for shape functions. Let's start with the shape functions. We have 4 points for checking. So now I'm going to criteria for shape function. The first one is shape function equal or is equal to 1 for considered node. However, node number 1 x equal 0 because the node 1 is on the 0, 0 point. So that's mean n1 equal 1 minus, I want to substitute the value of x here for this x, because I will depend, or actually I want to check for the value of n1 and n2, so that I will assume all my values of x is here, this x and this x. So here x is 0 over L equal 1 because this part equal 0. So for the node 1 is okay. Node number 2, x equal L. However, n2 equal x over L, this part. Okay, I'm talking here in this part for the n2. X equal L, so L over L equal 1. Then move to second criteria is shape function is 0 for each for the other nodes. So here node number 1 x equal 0 n2 here, because actually is the opposite. For the criteria number 2, if we want to work on the node of number 1, you will work on the node number 2, or you take the node, or actually substitute your value in the node of number 2, because if you substitute your value of the x for the node number 1, okay, it will be 0. So no need to do or to substitute your value in the node number 1. Just opposite. Work on, for example, here, if I have a 2D element, let's take a triangle. Okay, this is 2D element. Okay, that means I have here node number 1, node number 2, and node number 3. If I want to check criteria for shape function for the node number 1, for example, okay, I will neglect this point, or I mean, let me to make it as simple. I take it node number 1 for this criteria, for this number 2. Node 1 equal n1 for the node 1 plus n2 node 2 plus node number 3. For this one, it will be already 0, so no need to spend your time, just neglect it and use number 2 and node number 3. Same with node number 2, for example. Here node number 2 equal node number 1 plus node number 2 plus node number 3. Neglect the node number 2 and take only node number 1 and node number 3. Same with node number 3 equal node 1 plus node 2 plus node 3. Neglect node number 3 and take only 1 and 2. So here in my example, I have only one element, 1D. Okay, so because I don't like to spend more time, just I want to show you how you derivation actually for and use criteria. So here n2 equal x over L, and the x is 0, so 0 over L equal 0. Now go to node number 2, x is L, so that n1 equal 1 plus L over, sorry, I'm very sorry, this is here minus. You will ask me how can I get substitute these values. Just I use this rule for the n1 and n2 only. Okay, then this one is equal 0, so 1 minus 1 is 0. So this criteria number 1 is okay, both of them equal 0, because the condition is equal, should be equal 0 for other nodes. So go to criteria number 3. Number 3 is the name of number 3 is called summation of shape function is 1, should be equal 1. Okay, then say summation for the all nodes ni equal 1. However, n1 plus n2 equal 1 minus x over L plus x over L equal 1. This one with this one already go is 0, and we have only this one, so the result is 1. The last condition or last criteria, criteria number 4, summation. Then I'm going to go or working with derivation, summation of derivation of shape function is 0. Actually here in our element we have 1D, and our element is on the x direction, so we will use only this one, summation equal dn1, the general rule, that means the derivation of node over derivation of x direction, on the x direction. If we have a 2D, we will say summation equal dni over dy. So you can derive on y direction. Same if we have a 3D element, derive on direction of z direction. But as I said before, we have only 1D element, so I will work only on x direction. So dn1 for the node number 1 over dx plus derivation for the node number 2 over derivation on x direction. Just substitute your value here, equal minus 1 over L plus 1 over L equal 0. So this one is okay, except because the condition is the derivation or summation of derivation equal 0. Okay, so here in this case, just I say all criteria is okay, and shape function accepted. That's all. And maybe I can show you in the next videos a whole example with numbers, and in the I will solve example and put it the check criteria for shape function in the next videos. Thank you so much.